and usually we are going to use that for getting that, using the generating function we are actually going to get that series. So today's topic would be Hermite polynomial or Hermite function. Okay, you can see this Hermite polynomial or Hermite function. That's the topic for today. It's denoted by h and x. You have to remember which are the functions which actually represents which polynomial. Okay, so we have looked into p and x and all, so just make sure that you have made a list so that you're not confused. Now, sometimes they don't mention which polynomial they are talking about, they will just write down whatever is the representation. So h and x is representing the Hermite polynomial or Hermite function, and if you take this h and x, this is actually solution of the Hermite differential equation. So this is your Hermite differential equation, which is kind of different from the Legendre polynomial. There is a 2x minus 1 term there, right? So it's kind of different, and by solution we mean that this y can be replaced by hn. So this is something which you've seen a number of times. So this is your Hermite differential equation, and here n is basically a constant. Okay, so if you just want to find a series for this, okay, uh, first it is assumed. Okay, let's write it down. So let's say the series is, let y is equal to summation n is equal to 0 to infinity a r x to the power k minus r. Okay, so this is, okay, this, let's mark this as number 2. Okay, is power series. Okay, basically it's called the power series. We are going to find out the values of a1, a2, a0, a1, a2 and so on. So that is our aim in this particular idea. We're going to discuss it. Okay, let's just do it and then we'll understand it better. Is power series solution of equation 1. We're looking for a solution, and let's say this is the solution. We use this trial solution and all. Okay, so this is also something similar. Okay, and what we are going to do now is we are going to let's just write it down, dy divided by dx. Okay, because we need d2 by dx square, dy dx and y. So y we have it, so let's find out what is dy dx. Okay, and we are going to just replace it. So as I keep on writing, you also keep on thinking and writing the answers. Okay, this is with respect to x, so this will be ar k minus r into k minus r minus 1, right? So this is one more expression. Let's mark this as 3. Okay, and then we can actually find out the second order differential equation. D square y dx square is equal to summation n is equal to 0 to infinity. This is ar, and this is k minus r. It will remain as it is, and then we will actually differentiate this. Okay, so that's important. So the x is there, x to the power k minus r minus 1. So I'll differentiate it, so I'll get it to be k minus r minus 1 into x to the power k minus r minus 2. So if I mark this, let's mark this as equation 4. Okay, so now what we can do is we can actually replace it. Okay, so let's just do this replacement here. Okay, so using uh, 2, 3 and 4 in 1. So we can use these 2, 3, 4 in 1, and let's just write it down, the entire thing. Okay, summation. What we have to do is you have to remember how does this Hermite differential equation looks like, and you have to remember what is the power series, and that's it. Okay, everything else is just adjustment. It's a kind of long, but then you'll get the hang of it if you just practice it once or twice. So this is k minus r minus 1 x to the power k minus r minus 2. Our aim is to find out this constant. Okay, ar, a0, a0, a1, a2 and so on. What is that value? Okay, that is the aim. So we're going to do it soon. Minus, there is a 2x there, so I'll write it down as 2x. Okay, and then I'll have dy dx, and then we are going to put the summation r is equal to 0 to infinity and dy dx is ar k minus r x to the power k minus r minus 1, right? So that's the next term, then plus of 2n, and then y is summation r is equal to 0 to infinity, and that's the original series ar x to the power k minus r is equal to 0. Okay, so we have written the expression now, and let's just do the adjustments. So we can see something common here. There is an x here, okay, and then there is a minus 1 here. So if you just take up the power, it will be x to the power k minus r. Okay, so if it will be x to the power k minus r, so if we just write it down this way, we can actually take it up like this. Summation r is equal to 0 to infinity, and we have got this term. There is no addition to it, so we can just simply write it down as ar k minus r, and this is k minus r minus 1, and this is x to the power k minus r minus 2. So there is no change in this. For the second one, we can actually do certain changes. You see there is a 2 here, and then there is a 2 here, so I can take the 2 common. I can take this 2 common, and then I can put summation r is equal to 0 to infinity. Now if you check here, we have got an ar here, we have got an ar here, so let's take that ar also common, ar also common, and this is x to the power k minus r minus 1, this power is 1, so this will be x to the power k minus r, right? So that means I can write this down as x to the power k minus r, so this also can be taken common. X to the power k minus r, this will also become x to the power k minus r. What we have left out in bracket is n, this n that we have, and then we have got x we've done, so it is, there is a minus sign here, so it will be n minus k, and this minus and this minus, it will become plus, so it will n minus k plus r. So this is the expression that we have, after putting in all the results. Okay, and let's see what we can do now. So we have this result, and we are going to equate the coefficient of highest power. Okay, equate the coefficient of highest power of x. Okay, so let me just write down these sentences here. Okay, maybe I can just use the space here properly. Let's just write it like this. So now what we are going to do is equate the coefficient of highest power of x. Let's have a look. What is the highest power of x? That is x to the power k to 0, because on the left right hand side we have got 0, so we have to equate it with that. Okay, so if I want x to the power k, I have to put r is equal to 0. R is equal to 0, if I put, I'll get this x to the power k. Okay, so that means if I mark this expression, okay, we have marked up to 4. Let's mark an expression, otherwise it will be confusing. So let's mark this expression as 5. Okay, so that means this is 0 by putting r is equal to 0 in 5, right? It's quite obvious. So let's just put r is equal to 0. We actually see that this is 2 times. We have just taken r is equal to 0, so we can get rid of this summation. We have just taken one value, and this is ar, so this will become a naught, and then this will be n minus k plus r, so r is 0, so that means I can just simply write it down as n minus k, and this is obviously x to the power k, highest power, so just taking the coefficient is equal to 0. So if we just do a naught, this goes off, then it will be nothing but n is equal to k. That's my relation, okay, and that's, let's say, write down the relation 6. This is very important. When we look into this power series, n and k will more or less be the same, okay, so you have to just take care of this. So it's important, okay. One more thing, I think I made a mistake somewhere. I think the summation thing, right, it is not n, obviously it's r, right? We're putting r as 0 na. तो ये थोड़ा correct कर लेना तुम लोग. This is r, right? Someone should have stopped me. I don't have any n in the power series. This is r, okay, not n. This side I've written it correctly. There by mistake I've written n. So n is equal to k, okay. So we have to remember this. So we have equated the coefficient of highest power k, x to the power k. The next power would be nothing but x to the power k minus 1. Why we are doing this, you will soon know. K minus 1 will be the next highest power. That means r should be put as 1 now, okay. So let's take one more, okay. So let's say I want to equate coefficient, please write down the full word here, okay, of x to the power k minus 1 to 0, okay. So let's do it. So that means now I'll put a is 1, so r is 1, sorry, so this will be 2a1, and this will be n minus k plus r is 1, is equal to 0. Because if you look into the expression here, this is, even if you put r is equal to 1, it will be k minus 3. So it's not going to be the highest this power of k minus 1, right? So that means this also is going to be only from this particular term, not from the other term. So we'll just equate it with 0 again, okay. And if we look here, we can say that a1 would be 0 for sure, okay. This is simple, I guess. N minus k plus 1 cannot be equal to 0. It's very obvious, because in the last step we have seen that n is equal to k, right? So if we just put n is equal to k here, you can just write down k minus k plus 1 is not equal to 0, obviously, because k gets cancelled and 1 is obviously not equal to 0. So that means this expression cannot be 0. This will only be satisfied if a1 is equal to 0. So this is a very important result. We have actually found out what is the coefficient a1. The aim is to find out a0, a1, a2 and so on, okay. So this is something which we are doing here. So a1 is actually 0. We have to check that out. We have to keep this in mind, okay. Can we put something else now, okay. In uh, power of, this is n minus k minus 2, right? Sorry, not n, it is, okay, in power of k minus r minus 2. Where do we get that? This one, k minus r minus 2, okay. This one we can actually make it to be the power of k minus r. You'll soon know why I'm doing this. Put, I want to make it as k minus r, okay. That means if I put r is equal to r minus 2, so if you open the bracket it will be minus r plus 2, 2 will get cancelled, okay. We basically can have the power to be k minus r, okay. So if you put this minus 2, this will become k minus r. So we can get one more series where we actually have the coefficient of k minus r, okay. So next step is equate coefficient of x to the power k minus r to 0. Let's do it. So if we take the first term, this would be a r minus 2. Just check your notes here. K minus r plus 2. That means in place of r, I'm going to put r minus 2. Let's check it once. In place of r, I'm going to put r minus 2. k minus r minus 2, so it will be k minus r plus 2. In place of r I'm going to put r minus 2, that means k minus r plus 2 minus 1. Okay, so this will be k minus r plus 1. Okay, that way. So if to just check what happens when you put r minus 2 in place of r, so we can have k minus r plus 1. That's the term we have from the first expression. What about the second expression? Can we get k minus r? The answer is yes, because uh, you have it as k minus r. Okay, and this particular expression also, you should be getting it. Where is it? Yeah, this one, right? Yeah, so it is in the first expression. Okay, k minus r, and if you look into the second expression, this is already k minus r. You don't have to change anything here. Okay, here it's, if you put r is r minus 2, you get it. Here you don't have to change anything, that means you can just keep it as it is. That's the coefficient of x to the power k minus r from the second term. Okay, so please check this out. Okay, so that means from the second term I will get the expression as 2ar. It will remain the same, n minus k plus r. Okay, it is something like you want to find out what is the coefficient of x to the power k minus r, and there is a summation everywhere. So if you expand this summation, you will get one term which is k minus r. This also, if you expand this, there is a term which will having k x to the power k minus r. So we are just equating the coefficient of whatever is there for x to the power k minus r. Okay, because this is a series. Please don't get confused. We are not doing any kind of replacements here. This is a series. I want to know that for what value of r I'm getting k minus r. Okay, here it doesn't change, it's actually there, this term already is there, and here if r is r minus 2, then only I get k minus r. So that's why I can actually take both of them together and have it. Okay, so this is equal to 0, and that means that I can simply have a relation between ar and ar minus 2. So let's see, we can write down ar as, this can be taken on this side, so this will be minus k minus r plus 2, and then this is k minus r plus 1 into ar minus 2, ar minus 2. So this is 1, and then you divide it by whatever is left out here. So we have it as divided by 2 times n minus k plus r. So this way, you actually have a relation, okay, between r and r minus 2. That means you can put the value of r and you can get the corresponding value of r minus 2. Okay, so that is what we are going to do now, and we are going to find out the entire series. Okay, now you know that why we have done so many steps here. So that means we already know that, okay, let me just replace it here. Since n is equal to k, we have found out, that is why we are using that result. Okay, so see, we have already found out n is equal to k, and this is where we are going to use it. This is very important, you should not miss this step. Okay, so that means I can simply write it down as ar is equal to minus, in place of k I will put n, it will be n minus r, okay, plus 2. In place of k again I'll put n, so it is n minus r plus 1 divided by 2 times of r. Okay, because this is r, this is not 1, so it is n. In place of n I'll put k, so k minus k will go out, and then we'll just have r, and then we have got the expression as a r minus 2. Okay, so let's just mark this as equation 8, because this equation 8 is going to give me all the constants. Okay, so let's put r is equal to 2. So let's just find out the constants here. Put r is equal to 2 in 8. So we'll put r is equal to 2 in 8. So that means we can simply write it down as a2 is equal to, there is a minus here, so r is 2, so minus 2 plus 2 will get cancelled, so I can just simply write it down as minus n into r is 2, so minus 2 plus 1, so it is minus 1, n minus 1. See, it's looking like a series now. We'll eventually see that yes, it does become a series. So this can be written as 2 into 2. Okay, and then this is a r minus 2, which is nothing but a naught. Don't miss out this a naught, that's very important. We can rewrite this expression as minus n minus 1 a naught divided by, we can write it down as 2 square into 1 factorial. This is number 9. Mark this as number 9. Okay, we're going to find out the entire series now. Okay, we are halfway done. Putting r is equal to 3 in 8. Let's put r is equal to 3 in expression 8. Let's see what happens. So we are going to get a3 is equal to minus n. Okay, let's take it to be 3, right? So this is n and minus r, so r is 3, so minus 3 plus 2, so this is n minus 1, and then this is 3 minus minus 3 plus 1, so it is 2, so it is n minus 2. This is n minus 2, okay, and n minus 3, and then this is r minus 2, so this is 3 minus 2, so that is a1, right? So you can write it down as a1, and at the bottom we can actually have it as 2 into 3. But then we have found out a very important result in the previous slide, okay, and we have written here, okay, a1, you know, okay, uh, yeah, this one, expression 1, a1 is 0, right? A1 is 0, so this is multiplied by a1, matlab this is going to be 0, okay, and eventually you will see, okay, this is 0 because since a1 is equal to 0. Now if this is actually 0, okay, there is something which you are going to get for all the odd terms, okay, so that means if we just look into the similar property here, similarly a5 is equal to a7 is equal to, and so on, it's going to be 0. That means if we just look into the series now, let's just have a look here. This is the series. All the odd terms are going to be 0. a1, a3, a5 are going to be 0. That means we are just going to be left out with the even terms. Okay, so this is a very important observation. That's why we are actually going to use it. Now let's just put r is equal to 4 and let's check what is happening. We don't need to check for 5, 7 and so on. Put r is equal to 4 in expression 8. We get basically have it as a4 is equal to, just keep this like this, minus, so this is n minus r plus 2, minus 4 plus 2 is minus 2, so it is n minus 2. This is minus 4 plus 1, so it is 3, so that's n minus 3, and then you are going to get it to be a r minus 2, so that is a2. A2 we have already found out to be this, so let's just replace whatever we got in a2, okay. So you know a2 is minus of n into n minus 1, so this will become plus, and then I will have an n here, and then I will have an n minus 1 here, and then I will have a2, oh sorry, a naught. So you know a naught is something which is going to be common everywhere, divided by this a2 is 2 square, so I can just simply write it down as 2 square, okay, into, you know, this is 2 times of r, so that means there is one more 2 here, this 2, and r, now r is 4, so that means this is going to be again a 2 square, so you need, this is 2 to the power 5 actually, okay. So this particular expression, okay, or this particular thing, what we can do is I'll just rub it off, okay, I hope you get it. There are 5 2's here, okay, so what we can do is this, we can actually write it down as 2 to the power 4 into 2 factorial, 2 factorial, right? 2 factorial is 2, so that means it's fine. So you know we are getting a pattern here, you see 2 square, 1 factorial, 2 to the power 4, 2 factorial, and so on. So let's just mark this as 10. So do it slowly but carefully, and I think this is a kind of sum which you don't need to practice again and again. It's not complicated. Okay, so that means we can actually find out the power series now. Okay, so what we can do is this: we have marked equation 2. You can check that that's actually the power series. From equation 2 we basically have it as y is equal to summation r is equal to 0 to infinity a r x to the power k minus r, okay, is equal to k is nothing but n. We have seen n and k are equal. We can write it down as r is equal to 0 to infinity a r x to the power n minus r. Okay, we can write it in this way. So that means if I just want to write down the series, I can simply write it down as y is equal to a naught x to the power n, right? Because 0, r is 0. The next term would be nothing but a1 x to the power n minus 1 plus a2 x to the power n minus 2 and so on. What does it mean? We have to just know what is the constant. So we know what is a0, what is a2, what is a4 and so on. These all constants all are actually 0. Okay, so that means we can just simply write it down as a0 x to the power n. A1 is 0, so the next term would be a2 x to the power n minus 2 plus next term is 0, so it will be a4 x to the power n minus 4. So there is a pattern that is getting followed. Okay, so you have to remember this. Since a0, sorry, a1 a3 is equal to 0. Okay, so we have this now. So we got the expression, and let's mark this as equation 4, and then we are going to replace, not 4, sorry, 11, right? 10 लिखा था, 11 होगा ये. So we are going to use 9 and 10 in 11. So if we use 9 and 10 in 11, we can simply write it down as y is equal to, now remember everywhere we had a0, so let's just take common as a0. First term में a0 ही है, so it's just x to the power n. a2 also we have found out in terms of a0, and if we check it, it's actually all minus. Okay, so see, a2 there is a minus, a4 it's a plus, so it's going to be alternate plus and minus. This is our a2. This is also having a0, so we're going to just replace it and write down whatever is there other than a0 within the bracket. So there is a minus, so I'll put minus. This was written as n into n minus 1 divided by 2 square into 1 factorial, okay, into x to the power n minus 2. This should not miss this. Okay, very important. Plus fourth a4, let's write on that also, n minus 1 n minus 2. We also got n minus 3 divided by 2 to the power 4 into 2 factorial into x to the power n minus 4 minus, and then so on. Alternate plus and minus will keep on continuing. Okay, now we actually can do certain adjustments here, certain changes, so that we can actually bring it into a series in a simplified form, x to the power n minus, now look here, this is n, this is n minus 1. This one can be written as n minus 2 factorial. We can have a term as n minus 2 factorial, and this would be nothing but 2 square into 1 factorial into n minus 2 factorial. N minus 2 factorial was never there, so we have to multiply and divide by n minus 2 factorial, and this is x to the power n minus 2. Similarly here also we can write down as n minus 1 n minus 2 n minus 3, and here I can include an additional term which is n minus 4 factorial. Since I've added multiplied with n minus 4 factorial, let's divide by n minus 4 factorial so that the result remains the same. 2 to the power 4 into 2 factorial and so on. If you take something like 5 factorial, we can actually have it as 5 and then uh, 5 minus 1 factorial, right? Obvious, 5 minus 1 is 4, so that means I can have it as 5 4 3 2 1. It's the same thing. Similarly, if I take n factorial, I can have it as n into n minus 1 factorial. So that means I can also write it as n minus 1, n minus 2, n minus 3, and then n minus 4 factorial. Same thing. So that means this term, which is nothing but n factorial, this term is also actually n factorial, right? That's quite obvious. So maybe we can just write it down accordingly. Let me see if I can squeeze in some space here. This is a naught, this is x to the power n minus, now this is n factorial, that's done. Okay, and 2 in the bottom, we can write it down as 2 to the power minus 2. In the numerator it's the same, divided by, we are left out with 1 factorial and n minus 2 factorial into x to the power n minus 2, right? In a similar way, we can write down the next term. We can have it as n factorial divided by 2 factorial now. Okay, n factorial by 2 factorial, and then I can have it as 2 to the power minus 4 divided by n minus 4 factorial. Please follow very carefully. You can do it on your own also. Even if I don't write down, it's obvious. Plus dot dot. So this is what we have. Okay, we have actually simplified things here. Okay, and then this a naught that we are actually talking about depends on us. Why? Because a naught is basically a constant and it can have any kind of value, right? We can consider a naught to be 1 also. Okay, so because we have found out all the other constants in terms of a naught, so a naught will actually define all the other constants like a2, a4, and so on. So to make the series like Hermite polynomial, okay, we have to do it in this way. If we put a naught is equal to 2 to the power n, okay, then not m n, then y is equal to h n x is equal to Hermite polynomial. Okay, so this will be your Hermite polynomial. So that means let's simplify this. H and x is equal to this entire term. Okay, you have to write down the entire term. Please do it. ठीक है, very important. ये वाला जो टर्म है यहाँ पे हम इसको ले लेंगे and we are going to paste it here. For me it's easy, copy paste. For you have to write it down again. ठीक है. Okay, so eraser. So this will be nothing but 2 to the power n. So this will be 2 to the power n. So if we just take this 2 to the power n within bracket, this is 2 to the power n, this is x to the power n, first term. So that means I can just simply write it down as 2x whole thing to the power n minus this is n factorial, and then this is 2 to the power n, this is 2 to the power minus 2. So why I have taken this on top. Okay, and then there is an x which is also having a power of n minus 2. So that means I can combine both these terms and write it down as 2x to the power n minus 2. Please let me repeat this again, okay? Just note it down. This is 2 to the power minus 2. This will be becoming, if we take it inside, this will be 2 to the power n minus 2. This is already x to the power n minus 2. So that means we can combine them and write it down as 2x to the power n minus 2. Okay, take a note there. Divided by factorial 1 into factorial n minus 2. So you see, this is a sequence which we can see where we are actually having most of these terms in terms of n minus 2, n minus 4 and so on. Similarly, the next term would be n factorial divided by 2 factorial into, this will be n minus 4 x to the power n minus 4, so I can write it down as 2x to the power n minus 4 divided by n minus 4 factorial and so on. Okay, so that's it. Okay, it's very simple. That means we have actually got the Hermite polynomial. So we can actually write it down in the form of a series, and how is like this. You can see the sequence now is equal to summation r is equal to 0 to what, we are going to decide it later. Let me just write it down here. I can write down this as minus 1 to the power r. Why minus 1? Because you know it's alternate plus and minus, so that's why minus 1 should be there. And then we have got 2x. Look here, check this only. This is 2x to the power, now you see this is n minus 2, right? So that means I can say that this 2 is changing, this is 2, this is 4 and so on. So that means this will be n minus 2r. Okay, 2r. So we are putting in series of r, okay, please note that. And then n factorial is there, here also it's there, so I can just put it n factorial divided by this is factorial 1, factorial 2. I can also write down factorial 0 here. Factorial 0 is 1, so that means I can simply write it down as r factorial. And this is n minus 2, n minus 4, again the same thing, so I can just write it down as n minus 2r factorial. You can check here. I put r is equal to 0. Do we get the first term? R is equal to 0. This is 1. This is 2x to the power n. This is 0. This is not there, okay, because this is factorial n and this is 0. So this is factorial n. So factorial n will get cancelled out, and r is equal to 0. Factorial 0 is 1. So that means I'll be left out only with 2x to the power n. Similarly, the next term, if you put r is equal to 1, this is minus, so we'll get a minus here. Factorial n already there. 2x to the power n minus 2 divided by factorial 1 n minus 2. So you can check that the series is actually working. But the thing is, what will be the limit of r? R is equal to 0 to what? Now you see, this power that we are saying, it's always greater than equal to 0, obviously, okay, because this we are talking about a series here. So that means n minus 2r should always be greater than or equal to 0, right? That's obvious. That means that this 2r is always greater than sorry, I'm taking it the other way now. So 2r के पहले minus है, please note it. You know the equality rules, right? So 2r will always be less than equal to n. So that means this r is always going to be less than equal to n by 2. That means the limit is not from r is equal to 0 to n. This is going to be r 0 to n by 2. The moment it becomes greater than n by 2, this part will become negative, which is not valid, right? If you look into the series, this is actually called the Hermite function. So this is a function which is, you know, not it's used, obviously, if you look into your syllabus, it's there, but Bessel and Legendre are used maximum, okay, when you are going to do you know, problems in quantum mechanics and all. You are going to see that Bessel and Legendre is something which is more used, and Hermite polynomial is not that much used, but still it's there in the syllabus, so we have to check it out. It's very important. जानना सब है, later on देखोगे कि हर एक चीज़ तो applicable नहीं हो रहा है. This is Hermite function. So the thing is, you have a differential form and you say that the Hermite function will satisfy it. That's why it is called the Hermite polynomial or Hermite differential equation. But then I want to know what is actually h and x. How does it look? Is it, if it's a series, how will the series look like? So we just taken a trial series here, and then we did some algebra and found out that the series should be something like this.